Hello, my name is Ted Hoxie. I was part of ens100 Group 3 for the CAD project. Our goal, or our mission, was to design a tool that could fit within a 3 by 3 by 6 and 9-inch tall box. So a small box, about yay big, see a picture of it up there, that would loosen and tighten Phillips head screws, flathead screws, hex tips, and Allen keys. And we had to design it in CAD and then use a 3D printer to print it out. Now this is challenging for our group because no one in our group had had any previous exposure to CAD software. So the product development started in class. We each came up with possible designs and sketched them out, and we ended up going with the T-multi-tool design, which is this plus-shaped design that you see right here. And we chose that design because it fulfilled all the functions that we needed, could fit in the box, and was the simplest and easiest to design in CAD. As I previously mentioned, none of us had had any CAD experience, so this whole process was quite difficult. So the first step was sourcing CAD software, and there's a lot of CAD software on the market, but we went with Autodesk Inventor because we had access to a free version. I know there's a few other software options that are free, but we just felt like Inventor would be the best one for us. And then we started doing research, watching lots of YouTube videos. And I know personally I watched a ton of videos, and throughout the process I still was having a lot of trouble making CAD work the way I wanted to, but we were able to get it to work pretty well. First we created the body, and then we had to extrude it, and then we created the individual heads, and we got the pieces, like the individual designs, off of Autodesk Inventor for the Phillips and flathead. But overall, using CAD was the hardest part of the whole process because we had a lot of problems saving our CAD files. We also had problems because different members of our group started the project in different CAD formats. Like, I know the one we ended up going with was Autodesk Inventor, but I think another member of my group also tried to build it in SolidWorks. So that was some of our early problems. And some challenges that we faced, other than just learning how to use CAD for the first time and designing a complex multi-tool. Sometimes we had problems coordinating. Everybody in our group couldn't make it to every CAD software meeting. One of the things that we messed up on is we missed, or we came unprepared to a meeting with Dan or Danny, which was unfortunate. We were supposed to have finished our CAD file, but we were having so much trouble that when the time of the meeting came around, we were not ready, so we didn't end up meeting with him. And that kind of sucked because that was a waste of money and Dan's time. And also, another challenge we had was just staying on topic. and moving the different CAD design from the software that we used into the software that the printer could take. So in production, the T multi-tool, which is what we're calling it, was printed using the F120 3D printer with ASA filament. When you print on CAD, you have the ability, when you print on the F120 printer, you have the ability to make it either solid or basically hollow, which is really cool because the printer stacks layers of the ASA filament melted on top of each other to form the shape. And that's how it works. So you can design it where it's all the way solid or basically hollow or anywhere in between. And we went with the lightest that we could get away with to save filament and money. But this ended up coming back to bite us because the first time we tried to use it, the flathead broke, so it had to be reprinted. So this is our bill of materials. As you can see, the biggest cost was technical time, $71.50 worth of technical time meeting with Danny. The equipment cost, which includes use of the printer, was only $1.28, and we only ended up using $2.48 worth of ASA filament. So our biggest cost by far was using the printer, and that is for a grand total of $75. So some recommendations to improve if we had more time. I would like to make it solid all the way through. Another thing that we could do is we could move the 5/8 like ratchet, or to turn the 5/8 bolt, that head, we could put that as a hole right in the middle of the T multi-tool, and then we could put an additional tool on it, and so it has 5 functions. That would be really cool. And we could print it out in metal, so it would actually be usable. I think it's a really cool product that could be really popular if people had it. I mean, I've never seen any kind of product like that, and just by using it a few times, I could tell that it's very useful. Alright, by the way, thank you, Professor, for giving me the opportunity to present. I apologize I wasn't in class, so I really appreciate this. Thank you. It's been a great semester.